Hey everyone, it's Miss Reese. I'm going to be going over page 6 of the toolkit on projectile motion. So first let's go ahead and read through the problem. When Joey dives off a diving board, the equation of his pathway can be modeled by h equals negative 16t squared plus 15t plus 12. So we have our two variables, and instead of x and y, we're using h, which would be our height in feet, and we're using t, which would be our time in seconds. And we can see those two variables modeled on our x and y axis here on our graph. Okay, so the first thing we're going to want to do is we're going to want to identify the a value of negative 16, our b value, which is 15, and our c value, which is 12. And what we are looking for is what is the height of the actual diving board. So that would be the initial height, or like our y-intercept. So if we're looking for a y-intercept, that means x is going to be 0. So we basically, or x is 0, or we can call it in this case t is 0. So what we can do is we can plug in, we can solve for our height. Okay, we're going to do negative 16. We're going to plug in a 0 squared plus 15 multiplied with 0 plus 12. So when we plug in 0, it makes it really easy. With 0 squared is just 0. 15 times 0 is going to be 0. So here we get our height is 12. So that's going to be our initial height, or what we call our y-axis. Okay. All right. So the next thing that we're looking for is what is Joey's maximum height. So in order to find the maximum height, we're almost thinking of this as a parabola that faces downward. We know it faces down because our a is negative 16. So if we're thinking about a maximum height, that would be the highest point of our parabola. Remember this, another name for that is called the vertex of the parabola. And how we find the vertex of the parabola is we need to do negative b over 2a. That gives us our x value, or in this case, our t value for that. So we already identified b as 15, so I'm going to plug in 15 here. We identified a as a negative 16, so I'm going to plug that in here. So that means our numerator will be negative 15, our denominator will be negative 32, and we're going to get a decimal value for this in our calculator. So I'm just going to pull out my calculator here. Negative 15 over negative 32, and we're going to put it into a decimal format. And usually I round to 3 decimal places, so I'm going to say that this is 0.468. We'll round to 469. Okay, so maximum height. This is actually t, which represents time. So we really haven't actually figured out the maximum height yet. We just know the time that he reaches that maximum height. So what we need to do now to figure out the other part to our coordinate here, the vertex, is we actually need to plug this value in here. So now in our calculator, we can plug in, and I'll actually write it out first, negative 16 multiplied with that 0.469 squared plus 15 multiplied with that value as well, plus 12. So on our calculator here, let me go ahead and multiply everything out. Make sure when you're using your calculator, you have parentheses set up as well. Okay, so this is going to simplify to 15.51. 515 will round to 516. So this is h equals, so we can say the height is 15.515. We'll make that 516. So we now have our vertex, this point right here. So let's write it as an actual coordinate. 0.469. So at a time of 0.469, the maximum height that Joey is reaching is 15.516 feet. So this is, remember, time in seconds, and then this would be our feet in height. Okay. Now we just want to figure out maybe what his height is after 1 second. So we know what his height is after 0.469 seconds, but for some questions, you might want to figure out after 1 second or 2 seconds or so forth. So now all we have to do is, well, we want to figure out the height after 1 second. Let's plug in 1 into our set of parentheses here. So we have height equals negative 16. We're going to multiply that with 1 squared. That's just going to be 1. 15 times 1, that's just going to be 15. And 12, so really our height is negative 16 plus 15 plus 12. Well, if we add negative 16 and 15 together, that would be negative 1 plus 12, that would be negative 11. I'm sorry, positive 11. Okay, so we have a height of 11, and that was after 1 second. So that would be another coordinate point of 1 comma 11. So we might have a few data points. Actually, we have 3 data points that we can plug into to make a graph eventually. And now what we're looking for is find the time it will take Joey to reach the water. So if we're thinking about when Joey reaches the water, he's going to have a height of 0. So, okay, that's going to be when he comes down off the parabola. So he starts maybe at 12 feet, he goes up, reaches maximum height, and then reaches the ground, okay? So we need to figure out, we're going to plug in 0 for time. Or no, we're figuring out time. So we're going to plug in 0 for height. So we need to use the quadratic formula to actually set this up. So remember our quadratic formula. Instead of x equals, it's t equals negative b. So we have a negative here. Our b is 15. Plus or minus the square root of b squared. So 15 squared minus 4ac all over 2a. So from here, we're just going to continue simplifying this. So we have a negative 15 plus or minus square root. 15 squared, 15 times 15, that's 225. And then I'm just going to go ahead and multiply the negative 4 with a negative 16 with 12 to get me one expression, and that's 768. And it actually ends up being a positive because we have 2 negatives multiplying by each other. And then that's all over 2 times negative 16, which is negative 32. So we'll continue simplifying from here. I'm going to go ahead and add what's underneath the radical. Let's do square root 225 plus 768. So we get square root 993. Let's just go ahead and get the decimal approximation for that. And that's going to simplify to 31.5. 511 will turn into 512 when we're rounding that. So let's rewrite this. We have negative 15 plus or minus the square root of 993. I'll go ahead and write this in between step, just as a reminder of how I got to that. And then remember, we said the square root of 993 was about 31.512. So we have 2 separate answers here. Time equals, when our height was 0, we have negative 15 plus that 31.512 all over negative 32. So that's going to be one of our solutions. And then our other solution will be negative 15 minus 31.512 all over negative 32. All right, so let's take a look at this. I'm going to set up my little fraction here. We have negative 15 plus 31.512. And that's going to be all over negative 32. So this will simplify to a height of that's negative. So we'll talk about that in just a moment. Or a time that's negative, rather, sorry. And then our time here, set up our fraction, negative 15 minus 31.512. That's going to be all over negative 32. Okay, so the time is 1.454. We'll round that to seconds. So if we think about the parabola, let me go back here. Our parabola is going to look kind of similar to this one here. We're almost imagining that we're starting off at a platform of 12 feet. So really, if the parabola were to continue, it would go into the negative section. But since we're talking about something that, is an actual time, we can't really have negative amount of time. So really, we're just going to consider that at a height of 0, the time was 1.454. So let's write that as a coordinate point. So 1.454, that's our time, the x, and our height was 0. So now we have a few different points that we can actually use to draw a sketch of the path. So here's one coordinate. Here's another coordinate. We had this coordinate here, and then also we didn't write the y-intercept as a coordinate, but remember our y-intercept would have been 0, 12. So if we want a rough sketch of this, our time really only goes up to 2 seconds or 1.5 seconds about. So let's just do 1 second here, 2 seconds here. Space them out just a little bit. Almost equidistant. And then for our height, it looks like our maximum height is going up to 15. So maybe we'll go by 5s. Let's do 5, 10, 15. And this is all in feet. So we're going to start with a point at 0, 12. So that'd be about here. Then we reach our maximum height at like half a second, 0.46, and then 15, a little above 15. And then we have a point at 111. This would be about here. And then we have a point at 1.5, almost, 0. It's about here. So this is just a rough sketch of what the parabola looks like. And I think it was because I didn't do these quite equidistant that it's not quite symmetrical, but that's what we've got. Thanks for watching this video, and make sure you join office hours if you have more questions on the projectile motion problems.